So hello everyone, I am Dhiraj Kumar of Engineering Physics third year of IT Roorkee, and today in this video I am going to discuss about the fingerprint biometric sensors. So, so we will start our discussion with what is fingerprint biometrics and how fingerprints are acquired on the given sensors. Then we will discuss about the type of these fingerprint sensors and then we compare those and find out the best possible sensors. Then at last we will see some of the application of these sensors in our day-to-day life. So before diving into its architecture parts, let's first discuss about the fingerprint biometrics. So the process of fingerprint biometrics involves capturing an image of a person's fingerprints and analyzing its unique features. So let's discuss what do we mean by unique features. So we know that everyone has a different fingerprint which constitute of ridges and valleys. These ridges and valleys combine and form a unique fingerprints. So ridges are the elongated and elevated part of our fingerprints and valleys are the areas between them. These ridges and valleys combine to form different patterns like ridge ending, bifurcation, trifurcation, islands, lakes, and it's comprises of many different patterns and these patterns combine to form a fingerprint which is complex, unique and very useful for authentication purpose. Further, we will dive into the architecture of fingerprint biometrics. So the first step is fingerprint scanning, which is also known as the fingerprint acquisition process, which we can done by using different sensors. We will later discuss it about in this video. After that, we will extract unique biometric features from the fingerprints and then map these unique biometric features to convert this into a digital form and then further we will send this to a microprocessor or Arduino to further processing of the given data. So in this video we will basically focus on the first step, that is fingerprint scanning or the fingerprint acquisition. So here we can see there are different kind of sensors which can be used to acquire fingerprints. So these are optical, capacitive and ultrasonic sensors. Now further let's discuss about optical sensors. Starting with optical fingerprint sensor, so this system illuminates fingerprint using a source which is basically LED or infrared. The light emitted in from the source falls on the ridges and valleys of fingerprint and then further it gets reflected back to the CCD or CMOS, which is basically coupled device or the complementary metal oxide semiconductor which captures the reflected light and create a digital image of fingerprint. So basically it create a light and dark pattern corresponding to ridges and the valleys. It is happen because there is some gap between surface of the prism and the valleys, and due to which the intensity of light reflected back from this region is different from the intensity of light reflected from the ridges. Further, the image sensor convert the light intensity into electrical signals, which are then digited and further processed using signal processing unit or a microprocessor. Further, we will discuss about the capacitive fingerprint sensor. As you can see that it consists of a small capacitor arrays arranged in a grid patterns. When finger is placed on this sensor, then the ridges and valleys of fingerprint alters the capacitance of the cell. It work on the principle that the capacitor are charged and when the ridges of fingerprint comes in contact with these charge capacitors, some charge transfer to the fingerprint of ridges of the fingerprint, and as there is a distance between the valleys and the capacitor plates, there is a variation in the capacitor of these charge capacitor plates. So each capacitor plate sends arrays and measure the capacitance between the finger surface and underlying electrodes. These change in capacitance are mapped across the sensor arrays to create a spatial representation of fingerprint and unique features. These changes in capacitance are then mapped. The last sensor that we are going to discuss about is ultrasonic fingerprint sensor. As the name suggests, this sensor emits ultrasonic sounds towards the surface and where fingerprint is placed. When the ultrasonic waves encounter the ridges and valleys of the fingerprint, they are partially reflected and absorbed based on the surface texture and density. So by analyzing the reflection and absorption, the surface construct a detailed three-dimensional image and of the fingerprint surface. This image contains information about fingerprints, ridges, valleys, and other features. This unique topography of fingerprints create a distinct acoustic signature which can be best for authentication purpose. Now we will going to compare these given sensors um, according to their size, accuracy, durability, and the cost efficiency. So first discuss the size. The optical sensors are big as it required camera for capturing the image of our fingerprint, and it's cannot be embedded in small devices like capacitive and ultrasound sensors. Discussing about the accuracy, the optical sensors and the capacitive sensors work on the principle of 2D mapping of the fingerprint, which is affected by the dirt and the water layer between our fingerprint and the sensing surface. But in ultrasound sensors, as we have seen that it work on the principle of three-dimensional modeling. Therefore, it's not affected by the presence of dirt and water between the fingerprint and the surface. Now let's discuss about durability and cost of these different sensors. So optical sensors are most durable when we compared with capacitive and ultrasound sensors, and the cost of capacitive sensors are very affordable as compared to optical and ultrasonic sensors. So here are some of the application of this fingerprint sensor. As most of you have seen this um, uh, biometric authentication device which you can use in attendance purposes in our hostels. This device basically use the optical sensor uh, as it is durable when compared to ultrasonic and capacitance sensors. And you have also seen in mobile phones there is a back or side mounted fingerprint sensors which is relatively affordable than this ultrasonic sensors which is comes in inbuilt display fingerprint sensor mobile phones, which is a little costly when compared to this back and side mounted fingerprint sensors. Some other application of fingerprint sensors are used in the banking sector. Like in banking sector, there is a use of verification of identity and authentication of customer, and in KYC, it's also needed by the bank employees. Another thing is many car companies are using nowadays is to using fingerprint sensor to unlock car or starting the engine of the car. So, so that's all from my side. Thank you everyone to being with me till the end.